Welcome to this screencast where we will discuss ways of combining statements using logical operators. Conjunction, disjunction, and negation are the examples we will cover here. In a previous screencast, we learned that a statement is simply an unambiguous assertion, that is, a declarative sentence that is either true or false, but not both. Ultimately, our goal is to learn how to prove mathematical statements. The foundation of these proofs is mathematical logic, and to understand the proof techniques that we will learn, it is important to have a solid understanding of basic logic. This will involve learning how to combine statements and determining if these combined statements are true or false based on the truth of the original statements we were combining. In written and spoken language, we combine statements all the time using words such as and or. In logic, these are examples of logical operators. A logical operator, or a connective, is used to combine one or more statements to create a compound statement. Throughout the following definitions, let's let P and Q represent arbitrary statements. The first logical operator we want to define is called a conjunction. The conjunction of P and Q is the compound statement that is read as P and Q, and it is denoted by a wedge symbol or an upside down V between the P and the Q. The compound statement P and Q is true only when both P and Q are true. The next logical operator is the disjunction of P and Q. This is the compound statement read as P or Q, and it is denoted by a wedge symbol like a V between the two statements. The compound statement P or Q is true only when at least one of P and Q is true. And I note that the or here is an inclusive or, meaning both P and Q could be true. Our third logical operator is the negation. The negation of P is the compound statement read as not P, and it is denoted by a symbol that looks like maybe a subtraction symbol with a small tail on the end of it. The compound statement not P is true only when P is false. That is, not P is the opposite of P. Let's look at a simple example illustrating the use of these three logical operators. In this example, let's let P be the statement, it is raining outside, and let Q be the statement, Johnny is sleeping. For part A, the conjunction of P and Q, or P and Q, means it is raining outside and Johnny is sleeping. Notice here that the conjunction symbol is replaced by the word and when we write it out in words. And then the general statement P is replaced by the specific statement, it is raining outside. And similarly for Q. In the next part of the example, let's consider the disjunction of P and Q. In words, this is read as, it is raining outside, or Johnny is sleeping. And then in example C, not P means it is not raining outside. Now when we say the phrase not P, we want to change it into a sentence that makes sense to us in our own language. So when we read not P, it does not say not it is raining outside. Instead we would read it as it is written here, it is not raining outside. In this example, we will make it a little more challenging by adding a third statement. P and Q are the same statements that they were before, but now we have a statement R, which is a polar bear is a mammal. And we want to consider the more complicated compound statement, P and not Q, or R. If we were to write this out in words, we would get it is raining outside and Johnny is not sleeping, or a polar bear is a mammal. Again, just like in the previous problem, the negation, not Q, is written as Johnny is not sleeping. And then we combine that with statement P using a conjunction, or and then we combine that with R using the disjunction, or the or statement, getting the final answer for this problem.